Guys, it's that time of year again. Summer starts to wind down a little bit and you get the fair starts up. For this particular fair, it's $10 to get in, and tokens, which will let you ride rides, buy food, drinks, whatever, tokens are 50 cents each. So the question is, if you've got $20, how many tokens can you buy? Today's objective is to solve two-step linear equations. We've already looked at solving one-step linear equations where there's just one thing to do. Well, now in a two-step, well, you guessed it, there are two things to do. And to see what kind of situations bring this up, let's go back to our fair situation. So here we have $10 to get in. Tokens are 50 cents each. And what we want to know is how many tokens can we get? Well, our tokens, if they're 50 cents each, I can say 0.5, that's how much each one costs, and I'll just say t for the number of tokens. This could be x, whatever, we just need a variable name. T seems to make sense for tokens. And then what we know is whatever that cost is for our tokens, excuse me, we also have to add $10 for the price of admission. And in total, how many of our tokens I buy, this has to add up to $20. And in order to find out how many tokens I get, this is the equation that I need to solve. And this is what we're going to look at solving. Things like this, where I have both multiplication or division and addition or subtraction going on in the same problem. So when we have more than one step, we have to do those operations in a certain order. For example, in that last problem, we had multiplication and addition. It matters which one I undo first. And to see why, let's look at what evaluating and solving look like. So let's take this example here. Say we have the expression 3 times x plus 2. And that's what we're going to have on this side. And then we go to the other side, and let's have the equation 3, there's my pen, 3x plus 2 equals 11. And for this case over here, for the purposes of evaluating, we're going to say that x is equal to 3. So we have a situation over here where we're evaluating and we're finding what this is going to be equal to eventually, and over here we're solving. We want to figure out what the variable is. So when I'm evaluating, I start with the number that the variable is equal to. I know that the variable is equal to 3, and so I can replace the x with a 3. And then I'm going to follow the order of operations. I do multiplication first, and then addition after that. 9 plus 2 is 11. So I started with the number the variable is equal to, did the order of operations, and ended up with what would eventually be over here. 3x plus 2 equals 11 when x equals 3. So I started with what the x was and ended up with this 11. If I look over here at the solving, I start with the number the expression is equal to, and then what I have to do is undo things. And we haven't talked, strictly speaking, how to do this yet, but I undo things until I figure out what x is equal to. So notice when I'm evaluating, I start with the value of x and work towards a number. When I'm solving, I start with a number and work towards the value of x. The moral of the story is they're complete opposites of each other. And so when I do the opposite of evaluating with solving, that means I have to do the opposite of the order of operations. So instead of starting with parentheses and then going for exponents and multiplication and division and addition and subtraction, I have to go the opposite way. So when I'm evaluating, I start here and go down. When I'm solving, I start here and work my way up. So what I can see is that I always have to undo addition and subtraction when solving before multiplication and division. This is going to always be the case, and it's worth memorizing. So let me say again, When you're solving a two-step equation, when it's some combination of multiplication or division and addition or subtraction, you always undo the addition or subtraction first, and then do any multiplication or division. So let's take a look at it. Example 1, we have 3x plus 5 equals 18. I need to isolate the variable, just like we did with one-step equations, so I have to undo this adding and undo this multiplying. And if I'm doing the opposite of the order of operations, I know that I need to undo the addition first. So to isolate the variable and get rid of this plus 5, I have to subtract 5 from both sides. And when I do that, I end up with 3x equals 15. Excuse me, not 15, 13. And then, when I look at this, I have a 3 in front of the x. That means we're going to be multiplying. So to undo multiplying, I divide. And when I do this, I'm going to get an answer that is not even. That is okay. There are two ways for you to write this. If you want to leave this as just 13 over 3, that is certainly no problem. You can also just take a decimal approximation of this. So that would be 4.3 repeating. Just put the bar over it to show that those 3's go on and on. Or if you want to get super fancy and write that as a mixed fraction, 4 1/3, you're welcome to do so. Whichever one makes more sense to you, these are all the solutions. But notice, I undo the addition or subtraction, and then I undo the multiplication or division. Always undo the multiplication, or undo the addition or subtraction first. So let's look at this one. 13 equals y minus 5, or y over 5, excuse me, minus 8. So I've got 13 equals, and I'm just copying it down so I've got a nice clean problem to work with. I want to isolate the y. I want to get it by itself, so I've got to get rid of dividing by 5, and I've got to get rid of subtracting 8. So we undo the addition or subtraction first, and I undo that by adding 8 to both sides. And when I do that, I'm going to end up with 21 on this side, and over here, the 8's cancel each other out, and I just end up with y over 5. To undo the dividing by 5, I do the opposite, the inverse operation, which would be multiplying by 5. And when I do this, I get 105 on this side and y on this side, because multiplying and dividing cancel each other out. And so there's my solution, 105 equals y. So again, undo the addition or subtraction, and then undo the multiplication or division. Also note that just as with one steps, I can substitute this back in to check and see if my answer is correct. In any case, when we look at this, we really like having that variable first, but it doesn't have to be that way. And in fact, just as we saw with one step, we can look at things where the variable does not come first, and it's still solved in the exact same way. Here I have negative 8 plus 6r equals 76. And again, I want to undo the addition or subtraction before the multiplication or division. So to undo subtracting 8, I add 8 to both sides. And now I get 6r is equal to 84. Now, again, to isolate the variable, to get rid of the 6 that's with the r, we're multiplying 6 times r. The inverse operation is to divide both sides by 6. These cancel out, and r is going to be 14. And so now I've got my solution. I can substitute that back in to make sure I'm right, but again, all I did was undo the addition or subtraction first, and then undo the multiplication or division. So one final example. I have 16 minus z over 2. I'm going to put a little mark through that z to kind of show that it's a letter. And again, I have addition, subtraction, and then multiplication or division equals 3. And so I take the addition or subtraction and undo it first. There's nothing in front of this 16, so I can imagine a plus sign there. So I would subtract 16 from both sides, leaving me with negative z over 2 equals, and then 3 minus 16 would be negative 13. Now, there are two ways to handle this with that negative sign that was in front. When I have a negative sign in front of a fraction, it is proper and okay to attach that negative sign either to the top or to the bottom. When we're solving, it's much nicer to attach it to whatever the number is. So one way I can work this is to say that this is z over negative 2 equals negative 13. Since we're dividing by negative 2, to undo that, I multiply both sides by negative 2, and I would find that z is equal to positive 26, and that would be my solution. The other way, and I don't recommend this because it's an extra step, but it's not necessarily wrong, is if you make this negative z over 2 equals negative 13, I still have to multiply both sides by whatever is on bottom. So I multiply both sides by 2, and I get negative z equals negative 26. But now that's like having a negative 1 in front of that z, so I have to divide both sides by negative 1 as well, and I still end up with z equals 26. Again, I recommend this first way, just attach the negative sign to the bottom, but it's not wrong to attach the negative sign to either one, and you will end up with your solution. So to quickly recap, two-step equation, doesn't matter how complicated it is or what else is going on. Undo any addition or subtraction first. So here to undo the adding 12, I subtract 12, which would leave me with 4x equals 24. And then undo any multiplication or division. Here I'm multiplying by 4. So to undo that, I would divide by 4. These cancel, leaving me with x equals 6. And that would be my solution. Now this, solving a two-step equation, is going to be foundational to solving much more difficult equations later on. All we're going to be doing is reducing more complicated equations to two-step equations. If you can solve this, this is going to be what we turn every other problem into. Good luck.